Okay, so this is section 6-4, and now we're going to look at graphs of polar coordinates. Now, we're only going to do one specific type of graph of polar coordinates. There are several different types of graphs that we can do, but we're just going to do one example of graphing in polar coordinates. We're doing the easiest example, and these are circles, and we're really only going to do a basic type of circle. So r is equal to a cosine theta, r equals a sine theta. Both give us circles, but they give us circles in different locations. If you have r equals just some constant times cosine theta, your circle is going to be on the side here. Now, if r is if a is positive, it's on the right. If a is negative, it'll be on this side. And if you have r equals sine theta, then and a is positive, now we have a circle up here. If a is negative, we had to have a circle down here. Okay, so keeping that in mind, now let's go ahead and just do one quick example. And we have r equals 4 cosine theta. Now let's go through the whole process of figuring out, well, how big is this circle? So rather than doing an xy table of coordinates, we are going to use theta and r. Okay, so let's look at 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. And we'll see if those are enough points. Okay, so plugging in 0, cosine of 0 is 1, times 4 is going to be 4. Plugging in pi over 6, well, that's root 3 over 2 times 4 is going to be 2 root 3, which is about 3.5. Pi over 3, well, cosine of pi over 3 is 1/2 times 4 is 2. Cosine of pi over 2 is 0 times 4 is still 0. Pi over 2 is going to be negative 1/2, or I'm sorry, negative 2. And then negative 3.5 and negative 4. So let's go ahead and plot those points. Starting at 0, we learned how to plot points in section 6-3. So 0, we're going out a radius of 1, 2, 3, 4. And then at pi over 6, we're going out a radius of about 3.5. So 1, 2, 3.5. At pi over 3, we're going out a radius of 2. So 1, 2. And then at pi over 2, we're going out 0. At 2 pi over 3, we're going out a radius of negative 2. So instead of going this way, we're going the opposite way. And then at 5 pi over 6, we're going negative 3.5. So 5 pi over 6 going the other way, 3.5. And then at pi, we're going negative 4, so pi, but negative 4 would go this way. So what we've actually done is start to finish, we've graphed this circle. Okay, and that's how we graph those circles. And if we had a sine function, it would be up here or down here. And that actually brings us to the end of section 6-4.